Hello guys, welcome to our class. For today we'll be looking at moments of a force. That is what we are going to be discussing today in this our lecture. We just discussed equilibrium of forces, and I hope you understood that topic. So we are going to be looking at moment of a force about a point. Okay, so please get your writing materials ready so that we can go straight to our class. This is Noble Science Tutors Online. I remain notable Michael. You can reach us via the WhatsApp number that is showing on your screen. If you are not subscribed to this channel, please subscribe, give us a like, give us a thumb up, click on the notification bell so that when we upload a new video, YouTube will notify you. So I hope you are ready for this class. So let's go straight, and you are welcome. So, moment of a force. What is the moment of a force? The moment of a force about a point is the product, or let me just say it is the turning effect or the force about that point. Okay, so it is the turning effect of the force about the point, and it is equal to the product of the force and the perpendicular distance of its line of action from the point. So assuming it's a force, and then this is the line of action, this is the point of action O. So the moment of this particular force is the turning effect of this force, and it's equals to the magnitude of this force times the perpendicular distance from this point, that is the line of action. Okay, so moment is actually force times distance, and the unit of moment is Newton meter. You know that force is in Newton and distance is in meters. I hope that is clear. So this is basically the definition of moment. Now, assuming the force is inclined, okay, at a perpendicular distance as shown by this particular drawing. So if the force is inclined at an angle to the horizontal, then the line of action of the force is this particular line that is meeting this at this angle of 90 degrees. So from trigonometry ratio, the force, the distance of the force is given by d sine theta. Okay, so from your trigonometrical ratios, okay, so as I said, if you consider this triangle, the perpendicular distance of this force to the line of action is OD. So if you have a system like this, the distance OD, if there's a right angle distance OD, you know as sine theta is equals to opposite over adjacent, which is OD, opposite over hypotenuse, which is OD all over D. So OD will be equals to D sine theta. Okay, so this is the distance, this particular distance. So which means that the moment will be equals to F times D sine theta. Okay, so you need to take note of this, and that is what we have here. All right, so that is that. Then if the force here is inclined at an angle like this, and then this is your point of rotation, what you do is that you resolve this force into vertical and horizontal component. Now the force that will cause this body to rotate will now be the vertical component of the force. Is that okay? So if you resolve this force into horizontal and vertical component, the vertical component of the force is F sine theta. We treated all this in some topics before. So the vertical component Fy is equals to F sine theta, and the horizontal component Fs is equals to F cos theta. So, but what is important to us here is F sine theta, because this is the force that will cause the body to rotate. Okay, So which means that the moment of this force, considering this particular situation scenario, the moment will be equals to d times f sine theta. Okay, so we can take note of these two equations that we have derived, so that we can use them to solve some problems on moments. Okay, solving problems on moments is not that difficult, but you should know where you are taking your moments from. Okay, you should know which direction you are taking moments from, because once you know the direction you are taking your moments from, it becomes very easy for you to solve any problem on moments. Okay, so you should also know that when you say a meter rule is uniform, if a meter rule is uniform, depending on the information that you are giving, right? If the informations are given to you, fine. But if they are not given to you and you say a meter rule is uniform, it means that, or you say a 1 meter rule, it means that meter is 100 centimeters meter rule. Okay, so and when you are measuring your distances, you measure from the end of the rule, depending on the question that you are giving. So we'll go straight and solve some problems on moments, right? We want to solve some problems on moments to drive home all that we have discussed now. All right, so let's just go straight. But before then, I want us to also look at the principles of moments, because you should know the principles of moments so that when you are solving any problem, you apply the principles to solve the problem. So let's look at the principles of moments. Okay, the principles of moments states that one, when a body is in equilibrium, the sum of the clockwise moments about any point is equal to the sum of the anticlockwise moments about the same point. Okay, so the sum of clockwise moments equals to sum of anti-clockwise moments. This should be anti. Sorry about this. So this should be anti-clockwise moments. Okay, anti-clockwise moments. So that is one of the principles of moment. When a body is in equilibrium, the sum of the clockwise moments about any point is equal to the sum of the anti-clockwise moments about the same point. So basically, if this body is in equilibrium, what they are telling you is that the sum of the clockwise moments, this is clockwise moment and these are anti-clockwise moments. So what they are telling you basically is that the sum of the clockwise moment are equal to the sum of the anti-clockwise moment. So even if I decide to represent this as a simple rule first, let me just do something like this. Sorry about my drawing. Okay, so maybe we have a weight here. Okay, and then you have another weight here. Okay, so this is your point of rotation O, your fulcrum. So point of rotation, and then you have a distance, maybe let's say distance A and B. Okay, so you have weight 1, and then you also have weight 2. Okay, so if you have a system like this, the clockwise moments are the moments or the force that will move this object in the clockwise direction. So this is clockwise, and this is anti-clockwise motion. So what that first principle is saying that the sum of the clockwise moment, that is like your clockwise moment here now is equal to W2 times B, and your anti-clockwise is W1 times A. So what that principle is saying that this is equal to this, right? That this is equal to this. Now when you have more than one forces, so you can have a setting like this. Okay, so the second principle is that the sum of the forces in one direction is called sum of the forces in the opposite direction. These are almost the same thing. Clockwise, anti-clockwise, opposite, or whatever, they are almost the same thing. Now, if you look at this particular setting, I said before that when you want to solve problems on moment, you have to choose a point where you can take your moments from. That is that point where you take your moment from. You're looking at it as the point of rotation. If at that point is like your fulcrum or your pivot, right? That is your pivot or your fulcrum. So if you look at this setting, you have 2 points where you have your T1 and T2. They are point D and C. Now, for you to rotate this object, you can take a moment about either point C or point D. But take note that the principle of movement states that the sum of clockwise moments equals to sum of anti-clockwise moments. So if we now decide to say C is our point of rotation, if this C is your point of rotation, this C, if it is your point of rotation, which forces or which moments are your clockwise moments? Now you have this is a clockwise moment, and because this one will rotate in this direction, definitely these ones will also come in this direction. Okay, I don't know if you understand that this will also come in this direction, so this will also form part of your clockwise moment. So if we take moment about C, your clockwise moment will be W1 times D3 plus T1 times D1. Okay, then your anti-clockwise moment will be this, because this is your point of rotation. So this will be your clockwise moment, which will be W times D2. So applying the principle of moment, we have that anti-clockwise moment is equals to clockwise moment. So W times D2 is equals to this, all this, and that's what we have, your W1 times D3 plus T1 times D1. Okay, so these are some of the statements of the principles of moment. Another one is this. It's another one. Okay, we've already stated this. Okay, so this is what we said now, that the sum of the forces in one direction is equal to the sum of the forces in the opposite direction. So if you have a setting like this, right, it means that T1 plus T2 is equal to W plus W1. So the upward forces is T1 plus T2, and then the downward force is W plus W1, and then according to the principle, this is equal to this. Okay, so these are the principles of moment that you really need to take note of. All right, so these are the principles of moment. Now let's try and solve some problems so that we'll not be talking without solving problems. All right, so this is a sample question that I want us to look at and then solve. Okay, so we say that a boy of mass 10 kg, sits at a distance of 1.5 meters from the pivot of a seesaw. Okay, if another boy of mass 20 kg sits at a distance 1.0 meters from the pivot, will the seesaw balance horizontally? So this is a question that you have been given. Now, one secret or one thing that you should know about moment is that in some cases they will give you the picture, they will draw it for you, so it becomes easy. But if it is not drawn for you, you have to draw it. Because like this question now, I cannot relate it to anything except I put it in drawing. Yes, I have to draw the picture. So you must be able to draw the picture according to the information that you are giving. If you are unable to draw the picture, then for you to get your right answer will be difficult for you. Now let's look at a seesaw, right? So in this particular instance, let's just draw the seesaw and then put a pivot. Okay, so this is like a seesaw, and then let's put, this is the pivot, this is the point of rotation of the seesaw. So okay, so they said that a boy is a point of rotation. Fine. So they said that a boy of mass 10 kg sits at a distance of 1.5 meters from the pivot of a seesaw. So which means that if the boy sits at this point, is the boy is 10 kg. The boy is 10 kg. Okay. So if it sits at that point, that means that this will be 1.5 meters. See, that's how you interpret questions or moments. So we have gotten this part of the question. Let's see. If another boy of mass 20 kg sits at a distance 1.0 from the pivot again, so assuming this other boy sits here and the mass of the ball is 20 kg, then the distance is 1.0 meters. You see, so we have gotten the picture that we need. This is what we need. So what you need to do now is to apply the principles of moment. Now the question is that, say with the seesaw balance horizontally, so if for the seesaw to balance horizontally, it means that the clockwise moment must be equal to the anti-clockwise moment. If they are not equal, then the seesaw will not balance horizontally. So yeah, let's see clockwise moments. Clockwise moments is equals to clockwise moment here is equals to this, which is equals to 20 times 1.0 times 1.0 times 10. Please, I'm converting the 20 kg to Newton, which is force, so that gives me 200 Newton. Okay, then anti-clockwise moment, this in turns anti-clockwise equals to this, which is 10 times 10, converting to Newton, times the distance, which is 1.5. So that again gives me 150 Newton. Okay, so if you look at these two values, you find out that this weight will not balance at the distances that these boys sat. So from what we have got now, it means that the clockwise moment is greater than the anti-clockwise moment. So this seesaw will not balance, but it will tilt towards the boy that has the greater weight. Okay, so simply put, that is just it. The seesaw will not balance, but it will tilt towards the boy that has a higher weight. Alright, so fine. I think this one is clear and simple. I hope this is understood and this is clear and simple for you to understand. Alright, so let's take another question. So this is another question, and this one says a body of mass 58 gram is suspended at the 20 centimeter mark of a uniform meter rule. The meter rule is adjusted on a pivot until it settles horizontally at the 40 centimeter mark. Determine the mass of the rule. And these are questions that comes always, and we really want you to take note of this question, and then please pay attention to how we are going to go about solving this problem, right? So say the body of mass 58 grams is suspended at the 20 centimeter. It means that you are taking your measurement from the end of the rule, that is from the zero mark of the rule. That is what they are telling you. So which means that this body of 58 grams, you suspend it at the zero mark of the rule. So let's draw the rule first. That is the first thing that you need to do. Okay, so this is the rule. So assuming we are taking measurement from this end A, assuming we are taking measurement from end A, it means that from 0 to 20, that is where we are suspending the body. Okay, so we are suspending the body at this one, and then the body is suspended at this 20 centimeter mark. It's 58 gram. Okay, so this is 20 centimeter mark. You put it there, 20 centimeter mark. Then they say that the meter rule is adjusted on a pivot until it settles horizontally at the 40 centimeter mark. Okay, so the meter rule settles as you are adjusting on the pivot, it settles at the 40 centimeter mark. So invariably, since the meter rule is uniform, the mass of the meter rule will act through the midpoint of the meter rule, which is the 50 centimeter mark, because they said the meter rule is uniform. So this meter rule now is 100 centimeters, so which means the weight will act through the midpoint of the meter rule. Now we are told that it balances at the 40 centimeter mark, so which means that this is your point of that is your fulcrum. So the 40 centimeter mark is from the zero end, so from here to this point is 40. So if from here to this point is 40, and we have said that if from this point to this point is 40, and we have said that from here to here is 20, which is the point of suspension of the mass, then from here to here should also be 20 to make it 40 centimeter. Then if from here is 40 and this is the midpoint, means that from this point to this point is equals to 10 centimeters. So it means that this point is equals to 10 centimeters. Now for moment, this is actually where students find it difficult to arrange. See, this is where students find it difficult to interpret and arrange the diagram the way it is stated in the question. And once you are unable to arrange and interpret the question on a diagram like this, it becomes difficult for you to solve the problem. It becomes difficult for you to solve the problem. So you really need to pay attention to these aspects. Is that okay? You need to pay attention to how this question is being interpreted. What I said is that the meter rule, since it is uniform, the mass of the meter is acting at the center, which is the 50 centimeter mark. Now, if the mass is acting at the 50 centimeter mark and you are balancing a weight at the 20 centimeter mark of the rule, you need to adjust it until it will balance horizontally. Okay, now they said that this meter rule balances at the 40 centimeter mark, and if it balances 40 centimeter mark, it means that if this from point A to the 58 gram mass is 20, then the other part of it will also be 20. So that means the total distance from the zero end to the balancing point to be 40 centimeter. Is that okay? So the distance from the 58 gram to the pivot now will be 20 centimeters, and the distance of the mass from the pivot is 10 centimeters. So once you have been able to draw the diagram like this, it becomes easy. Okay, so this is your clockwise moment and this is your anti-clockwise direction. So according to the principle of moment, say clockwise moment equals to anti-clockwise moments. Clockwise moments is equals to anti-clockwise. So equals to anti-clockwise moment. Okay, so your clockwise moment here is equals to mass times 10. Your anti-clockwise moment here is equals to 58 times 20. Okay, so your mass is equals to 58 times 20 all over 10. So when you work that out, you will have the mass to be equals to 116 grams. So the major problem with solving any question or moment is for you to be able to interpret the question in a drawing. Okay, so let's try another problem too. Let's try another problem, please. Okay, so in this particular instance, the drawing is given to you. So if the drawing is given to you, it makes life a little bit easy too. Alright, it makes life a little bit easy. So let's see how we can interpret this drawing. I really decided I need to solve some problems more on moment, because I know it's always like a challenge to students. So in this particular instance, remember when we said that upward force is equals to downward force, or that the force in one direction is equals to the forces in the opposite direction. That is the first statement that you make when you see a question where you have 2 points of suspension for your meter rule or for your weight, because these are reaction forces. So these two reaction forces, they are equals to the downward force or the width of the meter rule. Okay, so once we have known that, we can see that for this, we can say that upward force equals to downward force, which is P plus Q is equals to 10 Newton. So this is your first statement. This is your first statement. Now, as I said before, since you have 2 points of balance or 2 reaction points, you can take moment about any of the points. Because here, say a light beam AB sits on 2 pivots C and D. A load of 10 Newton hangs at O, which is 2 meters from the pivot C. Find the value of the reaction forces at P and Q. Use the distances in the diagram given to you. Okay, so this is your first statement about this question. Is your first statement that the upward force equals to the downward force. That one is taken. Now, if we take moments about Q, it means Q will become our rotating points. Q will become our rotating point. So if Q is our rotating point, see, when you are taking moment about a particular point, forget about these other points. Is that okay? So now you are not looking at this C. What you are looking at is D. So if we take moment about Q, that's this point here. This point now becomes a rotating point. So which means that this will be your clockwise moment about this point, and then this will be your anti-clockwise moment about this particular point. Okay, so if you have that, it means that clockwise moment is equals to P force times distance, which is this reaction force times the distance from here to here is 8 times 8, and anti-clockwise is equals to 10 times 6. Okay, so applying the principle of moment, clockwise moment is equals to anti-clockwise moment. So we have P times 8 is equals to 10 times 6. So P will be equals to 10 times 6 all over 8. Okay, so by the time you work this out, you have a 7.5 Newton. Okay, so once you have gotten P, substitute it into this equation 1. We had from equation 1 that P plus Q is equals to 10 Newton. So which is 7.5 plus Q is equals to 10. So that Q will become 10 minus 7.5. So that gives us what? 2.5 Newton. Okay, so you see that for you to solve any problem on moment is for you to be able to interpret the question. Once you can interpret it, it comes out easily. Now, for this one, I will have taken moment about Q. So assuming we'll not take moment about P, because here we said taking moments about Q. Okay, so if you not take moments about P, how will it look like? So if we are taking moments about P, it means we are not going to consider this part again. We'll be looking at our focus now will be here. All right, so this P will now be our rotating point. Now if P is our rotating point, if we are taking moments about P, if we take moment about P, our clockwise moment will now be this, and our this will be our clockwise moment. Then this will be our anti-clockwise moments. Okay, this will be our anti-clockwise moment. So if we work that out, you will still have the same answer. If you work that out, you will still have the same answer. So assuming we start to take moment about P, you will have that. Okay, let me write at this corner. You will have that. We've already seen P plus Q is equal to 10 Newton. This one is okay. Okay. So if you are taking moments about P, you have your clockwise moment is equals to 10 times this distance. So you have 10 times 2, which equals to 20. This will be your clockwise moment. Then your anti-clockwise moment will be equals to Q times 8. Okay, so when you equate these two, you have Q times 8 equals to 20. Okay, so Q will now be equals to 20 over 8. So if you do that, you have 2.5 Newton, which is now your Q. Okay, so if you look at these two, you see that Q is 2.5 here, Q is 2.5 here, so it's basically the same. So for you to find your P, just to subtract this Q from 10, you will have P will be equals to 10 minus 2.5. Okay, so that gives you also 7.5 Newton. So you see that the answers are the same. Okay, so once your interpretation is correct, your answer will always be the same. I hope that one is clear. I hope that is clear. So let's just solve one more problem and see if we can get more understanding. See another question, another problem that we still need to solve. Say the uniform bar 15 meter long is balanced on a pivot placed at its midpoint, and a boy of mass 55 kg sits on one arm of the bar at a 0.5 meter away from the pivot. What mass can be placed 2 meters away from the other end of the bar to keep the bar horizontally? Okay, so what mass can be placed 2 meters away from the other end of the bar to keep the bar horizontally? Okay, so this one is basically just draw the picture. Okay, then assuming this is your pivot, the question says that the bar is A, B, and the length of the bar is given to you to be 15 meters. A boy of mass sits on the one arm of the bar at a 0.5 meter away from the pivot. So assuming this is the pivot, the boy sits 5 meters away. So here we'll put it at this 55 kg boy, and sits 5 meters away from the pivot. Okay, then the other boy, now take note, the meter rule balances at the center, so from this point to this point, that is half of the meter rule is 7.5. This is 7.5 meters, and also this part is also 7.5 meters. It's also 7.5 meters. Okay, so if this is 5 meters, then this ply will be 2.5 meters. Right, so I'm trying to interpret the question. So a mass is to be placed at 2 meters from the other end. So this is the mass, and from this other end is 2 meters away. So if this is 2 meters, it means the distance here will now be what? 5.5 meters. Okay, because since the meter will balance at the center, then this means this is 7.5 meter and this is 7.5 meter. Okay, so if this is 2 meters, then this will be some 5.5 meters. If this is 5 meters, then this will be 2.5 meters. Okay, so what I'm trying to say is that if from end B to M is 2 meters, then from M to the pivot is 5.5 meters. Why this side, if this is 5 meters away, then this side will 2.5 meters. Note that the meter rule is 15 meters long, so it balances at the center, the midpoint, which is 7.5 meters from both ends. Okay, so this is basically the interpretation of this question, and once you have interpreted it like this, every other thing is simple. What you just need to do is clockwise moments is equals to anti-clockwise moments, and once you have done that, your answer just come out readily. Okay, so from this one now, you have that your clockwise moment is m times 5.5 is equals to anti-clockwise moment, which is 55 times 5. So m is what you are looking for, so you can just have your 55 times 5 divided by 5.5. So when you work that out, you're going to have your answer to be equals to 50 kg. So you can see that in equation in moments, the area of concern is for you to interpret the drawing properly. Once you're able to interpret the drawing, your answer will come out readily. Is that okay? So this is, I think we solve a lot of problems on this, and then I have this as, I think this should be a last question for this particular topic. Alright, so this one is also one of the this that we discussed just now. Say, determine the magnitude of P in the diagram below. Okay, so as I said before, we said that when you have a system like this, what the main concern is the vertical force, right? And we said that the vertical component of this P, vertical component, is equals to, that is you say Py is equals to P sine theta. That was what we said. So this P sine theta now is the vertical component of this force P. Okay, the vertical component of the force P. Now, taking moment about this point, our clockwise moment is this, and then this is our anti-clockwise moment. So clockwise moment is equals to 40 times 20, which is equals to 80. Because your distance is 20 and the force is 40. So this is your clockwise moment. Okay, then your anti-clockwise moment is clockwise moment. Please take my abbreviation. Clockwise moment, that is anti-clockwise moment, is equals to the vertical component of the force, which is P sine 30 multiplied by the distance. Distance is 50. Multiplied by the distance, which is 40. Now, according to principle of moment, we said that clockwise moment, which is 80, is equals to anti-clockwise moment, which is P sine 30 times 50. Okay, so P which is what you are looking for, is equals to 80 all over 50 times sine 30. Okay, so 80 all over 50 times sine 30 is equals to 0.5. Sine 30 is equals to 0.5. So that gives you 80 40 times, that is 800. Sorry, I think I'm seeing that 800. Okay, 40 times 20 is 800, not 80. Okay, so that is that 800. So when you work this out, it will be 800 divided by 25. Okay, so if you divide that out, you have that P is equals to 32 Newton. 32 Newton. Okay, so P is equals to 32 Newton. Okay, so this is it, and this is how to apply this all the equations that we discussed in solving problems on moment. I think we've covered a lot on this, and I hope you understand it. Please go through the questions again. Try to understand how to interpret the questions. Is that okay? You really need to understand how to interpret the questions. So this is your test page. Please, I want you to go through all these questions and try to interpret them, then get your answers out readily. This one says a uniform beam PQ of mass 20 kg and length 5 meters is balanced as shown. A man of weight 800 newtons stands at M such that OM is 2 meters. The reactions at P and Q respectively are what? A uniform beam PQ of mass 20 kg. Okay, a uniform beam PQ of mass 20 kg. So if this beam is uniform and the mass is 20 kg, it means that this mass will be acting through the center of the beam. So don't forget that. The mass will be acting through the center of this beam, which is 20 kg. Then this weight is also at this 800 weight is at this point. I'm just trying to give you the hints. Then this is 20 kg here. So if you have this hint already, so you have two masses here, you can take moments about any bond when you have been able to balance these distances. So you balance these distances, right? Balance the distances. I've given you these hints. Balance the distances and solve for this problem, right? I think this should also be easy for you to solve. Let's see much problem here. Also this should be easy. We've solved problems like this already. This one, you need to crack your brain. So please guys, this is where we are stopping our class for today. Please solve your problems, and if you have any challenge, you can reach us through our WhatsApp number, right? So but before I go, please subscribe to our channel, give us a like, click on the notification bell, give us a thumbs up, give us positive comments, so that we can continue to dish out quality videos to you. Is that okay? So this is Number My Science Tutors Online. Thank you for your time. We are grateful for your time and for all that you are doing. So thanks a lot. Continue to study your books so that you can be a better you. Reach us through the WhatsApp number that is showing on your screen. And thank you so much for your time. See you in our next class.